Welcome the students in science class. Class 10, Unit 5, Light. Topics: lens, concave lens and convex lens, refraction of light by lens, image formed by convex lens, image formed by concave lens, defect of vision and their correction, magnification and power of lens, numerical. Lens. The optical instrument formed by part of spherical glass and used for converging or diverging of light is called lens. Convex lens. The lens with thick center and thin edges is called convex lens. It is also called converging lens. It is used for remedy of long-sightedness. Concave lens. The lens with thin center and thick edges is called concave lens. It is also called diverging lens. It is used for remedy of short-sightedness. Lens is the set of number of prisms. In convex lens, the central part is like thick glass slab, and the edges of one are thinner prisms. The angle of refraction becomes less while moving from edge to center. In concave lens, the central part is thin glass slab and the edges on are thicker prisms. The angles of refraction becomes less while moving from edge to the center. Information about lens. Principal axis. The imaginary line joining the center of curvature of lens is called principal axis. XY is principal axis. Center of curvature. The center of curve of imaginary sphere with which lens is made is called center of curvature. C1 and C2 are center of curvature. Optical center. The point on principal axis which is equidistant from surface of lens is called optical center. O is optical center. Principal focus. The point on principal axis at which the rays of light converges is called principal focus. F is the principal focus. Rules of refraction of light. A. The ray of light traveling parallel to the principal axis passes through the focal point after refraction. B. The ray of light passing through optical center passes straight. C. The ray of light coming from focus passes being parallel to the principal axis after refraction. Image formed by convex lens. A. When object is placed at 2f, nature of image formed. 1. Real. 2. Inverted. 3. Same size to object. 4. Formed at 2f. B. When object is placed beyond 2f. Nature of image formed. 1. Real. 2. Inverted. 3. Smaller than object. 4. Formed between f and 2f. C. When object is placed in between f and 2f. Nature of image formed. 1. Real. 2. Inverted. 3. Magnified image. 4. Formed beyond 2f. D. When object is placed at f. Nature of image formed. 1. Real. 2. Inverted. 3. Highly magnified image. 4. Formed at infinity. E. When object is placed at between f and o. Nature of image formed. 1. Vertical. 2. Upright. 3. Magnified image. 4. Formed behind the object. Image formed by concave lens. Nature of image formed. 1. Vertical. 2. Upright. 3. Smaller than object. 4. Formed between f and o. Power of lens. The capacity of converging or diverging the rays of light by lens is called power of lens. It is denoted by capital P and its unit is diopter. Mathematically, power of lens equals to 1 upon focal length. Focal length must be in meter. Convex lens is positive lens. Concave lens is negative lens. Magnification. The ratio of height of image to the height of object is called magnification. The ratio of image distance to the object distance is called magnification. Mathematically, magnification equals to image distance P upon object distance U. Defect of vision. The problem in which the eye cannot see the near object or far object clearly is called defect of vision. Myopia. The defect of vision in which the eye cannot see far object clearly but can see near object clearly is called myopia. It is also called short-sightedness. Causes of myopia. 1. Thickening of eye lens. 2. Elongation of eyeball. Correction of myopia. It is corrected by using concave lens because concave lens diverges the ray of light and forms image at retina. Hypermetropia. The defect of vision in which the eye cannot see near object clearly but can see far object clearly is called hypermetropia. It is also called long-sightedness. Causes of hypermetropia. 1. Thinning of eye lens. 2. Shortening of eyeball. Correction of hypermetropia. It is corrected by using convex lens because convex lens converges the ray of light and forms image at retina. Lens equation. 1 upon f equals to 1 upon u plus 1 upon v, where f is focal length, u is object distance, and v is image distance. Numericals. 1. Calculate the power of convex lens of focal length 20 cm. Solution. Power of lens P equals to what? Focal length f equals to 20 cm equals to 0.2 meter. We know P equals to 1 upon f or P equals to 1 upon 0.2 or P equals to 5. Therefore, P equals to 5 diopter. 2. Calculate the focal length of lens of power plus 5 diopter. Name the types of lens 2. Solution. Power of lens P equals to plus 5 diopter. Focal length f equals to what? We know P equals to 1 upon f or 5 equals to 1 upon f. or f equals to 1 upon 5, or f equals to 0.2 meter, or f equals to 0.2 into 100 centimeter. Therefore, f equals to 20 centimeter. The lens is convex lens. Three. The power of a lens is 25 diopter. If a person wants to read a book, how far must the book be held from the lens? Solution. Power of lens P equals to 25 diopter. Focal length F equals to what? We know P equals to 1 upon F, or 25 equals to 1 upon F, or 25 F equals to 1. Or f equals to 1 upon 25, or f equals to 0.04 meter. Therefore, f equals to 4 centimeter. 4. A burning candle is placed at a distance of 15 centimeter from a convex lens with focal length of 20 centimeter. Draw the ray diagram to show the formation of image. Write the nature of image. What is the power of lens? Solution. Power of lens P equals to what? Object distance U equals to 15 centimeter. Focal length F equals to 20 centimeter equals to 0.2 meter. We know P equals to 1 upon F, or P equals to 1 upon 0.2, or P equals to 5. Therefore, P equals to 5 diopter. Nature of image. 1. Virtual image. 2. Upright image. 3. Formed behind lens. 4. Magnified image.